Hello and welcome to this tutorial explaining how to use the Carbon Crease node. Here we have a basic simulation of a square cloth mesh falling onto a carbon collider. Let's reset the simulation and press play. Nothing much happens because the cloth was just placed pretty nicely on the collider. Alright, let's go ahead and create a crease node. We press tab, go to the carbon entry, and then we go to utilities and we find the Carbon Crease node. Otherwise, you can just press tab and start typing crease, and you find Carbon Crease here as well. All right, we obviously only need one, so let's delete the second one. Okay, let's go back to our mesh, and we can see that the crease geometry, let me hide this, is already accounted for. So we have a line going straight through the mesh, and this is where we want to apply our crease. Let's go into selection mode up here, select edges, and click the cursor to select. Select the first edge, press Shift A, and allows us to select a whole line initially. Okay, we can't go all the way through. Let's select this, hold Shift and select the final one. Press tab and start typing group. We're gonna create a group. It automatically sets to edge group. Let's pick the name, crease. For the group name, we just do $OS, which says use the node name as my group name. And let's make it ordered. Perfect. Now we have our crease group set up in here. We can now bring this into our Carbon Crease node. All right, on our Carbon Crease node, now just say we want one crease and we point to our edges group crease. Okay, we have a couple other parameters, which are angle and strength. What does the angle do? The angle here either replaces, adds, or blends with the existing angle on the mesh. And with that mean we're on the reference mesh. So these angles will be replaced, added, and blended with the reference angles on our carbon cloth. Now our carbon cloth reference mesh, well, we don't have one. We don't have anything connected to it, which means our start mesh will be used as the reference mesh from which the reference angles will be extracted. But our start mesh is flat, as we can tell, so all the angles are 0, which means whatever we do here, replace, add, or blend, we will do this with 0. If you go to blend, we can see the extra blend parameter 0 to 1 popping up. Well, usually I just stick with replace because I don't want to be affected by whatever is in the start mesh or reference mesh. I'm just going to go override the existing angles. Now, if I go with 0, nothing happens. So let's set it to 90 to actually get some behavior. I'm now going to connect the crease into the 4th input of the cloth. Let's press LH to lay out the graph and Ctrl S to save the scene. Back to our simulation. Reset the simulation and press play. Well, nothing happens. Why is this? Well, nothing happens because A, we have very low conversions of the simulation. We have 10 iterations and 10 subdivisions only. Furthermore, our carbon cloth bend stiffness, which is here set to 0.1, is very weak, which means our cloth can bend easily, like a cotton t-shirt, unlike a leather or a very stiff denim, which are harder to bend. So which means less bend stiffness, less strength to enforce our angle. If you were to increase our bend stiffness to 100, and let's say we increase our subdivisions to 100 for more convergence, run the simulation again, we can see a much stronger result. But now we obviously have the side effect. We have change our simulation parameters to make the simulation slower. Well, yes, it converged better, but maybe we don't want that. Maybe we're happy with 10 because the rest of the simulation looks nice. So let's revert this. And B, we've increased the bend stiffness of the whole cloth, which is also not what we want because we want it to behave like a cotton. We don't want to make everything stiff. So how can we enforce the crease only? Well, this is the strength parameter on the Carbon Crease node. So I set this one to 100 and see what happens. All right, and run the simulation. And there we go. We immediately have a crease. Sometimes a value of 50 or a value of 10 might be enough. So let's try 50, or let's try 10 and see what happens. All right, that's not quite strong enough. So 100 was actually pretty good. All right, now keep in mind that our angles are signed. So 90 is in one direction. If I go to minus 90, reset the simulation, we should now see the crease, yes, pop in the other direction. Instead of down, it's going up. On the first frame, you can see a very big jump going from flat to this. This is because the reference overrides what is in the start. The start has an angle of 0, and we override to minus 90, so you can see a very strong pop. You might not necessarily want this to happen so strongly, and you can use lead duration. In this example, we're fine, but let's see what happens when we change this. Now first, we're gonna go set it to 180 to basically fold this piece over, or at least enforce an angle in this area. Let's go to reset simulation and run this. And we're gonna get a very unhappy simulation. Now there's two reasons for this. First of all, we're applying a very strong angle with 180 degrees. So we're telling the simulation on the first frame, instead of flat, we actually want this to go over there. So that is too much. That's where we need to bring in lead simulation. The other thing is that 180 degrees is a perfectly folded over angle. But this is not really possible because obviously the material has thickness, as you can tell. So when you try to fold it 180 perfect fold, you have the material fighting with itself. You get collision issues. And now you have a strong strength fighting the collision. We're going to end up with all of these problems. So what you can do is, instead of 180, actually say 170, which is still very close, but allows some extra freedom for the crease to have no problem with the collision. Let's run the simulation now and see where we end up. There we go. That's a bit better. And as I said, maybe you want to add some lead duration to not really enforce this all the way on the first frame, but give it a little bit lead simulation to ease into it. There we go. And now this looks much smoother. Look at this. This has come together really nicely and very calmly. And this is really what you want to do with very large simulations as well, where you have lots of creases going on. But yeah, I hope this all makes sense and you have fun using this node. Thank you for watching.